thank you guys very much for taking the time to join us here, taking time out of your day. Hopefully we'll give you some quality information on troubleshooting an E1 error code. What we're going to cover today is where to find help, confirming proper installation and operation, troubleshooting test points, troubleshooting with test tools, and then we've got some tips and tricks to share with you. So where to find help, we're going to continue to put more information out on greecomfort.com. So please take a look out there. Just go to greecomfort.com. Under instructional videos and FAQs, we're going to continue to upload quick tip videos. We're going to try and take these. This is a pretty comprehensive class today, but we're going to try and condense those down into a real quick 2-3 minute quick tip. So you can go out there when you're on the job, you can go to that quick tip, find a fast answer, hopefully get your customer up and running and be off to the next job. So make sure to look at the informational videos and FAQs, go to quick tips and you'll find them there. You can also, from greecomfort.com, go to system documentation and literature. We're going to continue to add updated literature to those as well. We're going to try and add improved service manual. This will be our own service manual that we create that has lots of information, useful information, test points. If you're using a meter on something and you need to know which terminals to touch and what readings you should get, we're going to try and put that information out there. Any helpful information that we can. We're developing other things as well, working on a phone app and other things that can help you in the field.
You've got a lot on your plate, Keith.
I do. Busy guy.
Exciting news. I'm glad to see that things are improving. And by the way, I didn't know we had a website.
Didn't know?
I didn't know.
Been out there for a little while, but so anyway, yeah, please be sure to keep an eye on that. You know, it is going to be changing, and there's hopefully going to be a lot more useful information for you guys out there. So if you're not a Gree Select dealer, I know most of the people on here are, but it's very easy to become a Gree Select dealer. Just attend a meeting and we'll get you signed up. And there's a lot of perks and benefits to becoming a Gree Select dealer. Extended warranties. We put you on the website as a potential source when customers in an area are looking for a good contractor that knows how to install these things. Your name will be populated on there, and there's lots of other benefits as well. So
excellent.
What we're going to do today, we're going to go to this skip to menu, go to single zone. We're going to look at the Vireo Gen 3 mainly. We're kind of focusing around that today in what we're going to discuss. And what you'll find out there is under single zones or any of the other multi-zones, all the individual models, you'll find installation owner's manuals, service manuals, and these are all in PDF format. So they're good for printing, for downloading, very useful for you out in the field. In the service manual, they show this E1 error code, you know, and they give you a brief description of possible causes. This is fairly light. They only have 3 items listed in here. We're going to talk about 11 different items today. And with these systems, it's just a matter of really understanding how the system operates and what things to check next. So we're going to look at the easy things first. Is the outdoor ambient temperature too high? Are the service valves open fully? Do you have dirty filters, coils, or obstructions? Is the stepper motor working properly? Indoor fan motor functioning properly? Condenser motor, and so on. And we're going to touch on each of these and hopefully give you a real good troubleshooting method for finding, for solving an E1. We're also making new troubleshooting flow charts that are more robust than what you'll find in service manuals. And so this is some of the information that's going to go out there to the website, and hopefully will help you get these problems solved a lot faster. We're going to confirm proper installation and operation. So talking about being in the within the operating temperature range, We've got these all models listed on a chart here that will show you some of the all the operating temperature ranges for these different products in cooling and in heating. If you're in an area that's very cold, you may want to consider migrating to something like the Vireo Gen 3, which has a much wider operating temperature range. If you're in Phoenix and it gets really hot out there, you may want to consider a Sapphire or some other model than you might be currently using if you're experiencing any type of issues having to do with operating outside the.
It goes back to best practices. Choose the correct model for the application.
Right. And if you need help with that, we can certainly help you with that as well. We have very well-schooled sales force and sales reps and people that can help you out. Us and technical can help you as well. So on this Vireo Gen 3, one of the potential causes, people will talk about a high pressure switch. Not all systems have high pressure switches. In fact, all of the mini split series have just a temperature sensor, discharge temperature sensor, and the 18,000 BTU multi-zone also has just a discharge temperature sensor. So it's actually pressure reading or a temperature reading being converted to a resistance value that the main board is going to do calculations to determine whether or not to initiate that E1. So a few things to check. So checking all the easy things first. You can do a lot of visual inspections, save yourself hopefully a lot of time and trouble, but verify that there are no splices or damage to the interconnecting cables. A splice or a fray in the interconnecting cables can, even an improperly rated cable can cause an E1 error. Verify that all the panels on the equipment are tight and tightly secured on there. Those can throw off sensor readings as well.
The frayed wire is something that we questioned for a long time, and Richard did a lot of research and lab testing, and I've actually had several cases where I had a damaged wire and it was actually causing the E1 error code. You got to keep in mind, Keith, that the E1 error code is but a symptom. It could be a lot of different things, and not just to mention frayed or damaged control cable or interconnecting cable, also grounding as well. I've had several instances with our friends up in upstate New York where it's been a grounding issue that was sometimes causing E1, but also causing some random other error codes to pop up for what appeared to be no reason.
Right. Yeah, the grounding can cause those random error codes and things. So it's always important to check that. Just make sure they're tight and secure. Let's see. And then move to the service valves. Surprisingly enough, this does happen, but are both service valves fully opened? And, there are two on there. Sometimes someone will neglect to open one of them, and that's going to cause a high pressure situation that can give you that E1.
That's really easy to do on a multi-zone system where you've got 2 valves per indoor unit. So you got a bunch of valves that you have to make sure are opened all the way. Right.
Yeah, real good point. And the other thing is you don't have to wrench on these things when you're backing them out. Back them out, back them out gently. You don't have to put a cheater pipe on there to get them open fully, but back them out all the way and then just give them a little nudge back in, and you should be good to go. We've actually Richard in tech wrenched on those things just to see, how robust they were, what it would take, and he actually cranked one of the valves all the way out. So
it's called a non-backseating valve is the term that Richard schooled me on the difference between the two. And some manufacturers will have a note that says turn a quarter turn back in once you've backed it out, just to make sure that it's not going to leak.
Right, right. So that's a pretty important thing. You know, hearing that there's a leak in a service valve, you kind of scratch your head. And it's, how could there, if it's, you know, you always assume it's the connection, but cranking on those valves too hard can cause you a little problem. So something as simple as that, right?
But also, if you know the brass to brass surface of the cap that goes on it, if you torque it down closed, it will seal anything that may be behind there.
Right, right. So the other common thing, this is probably the most common thing, would you say, Daniel? Dirty filters,
Most certainly.
coils, and some kind of a blockage around the outdoor unit. Sometimes people don't like the way they look, and they'll plant a hedge back there or something, and that's not a good mix. So you know, test procedure for this, visual, obviously. Take a look at this condenser coil. That is,
oh, that's rough.
that's pretty dirty. And do you think that might cause an E1 error?
That could cause an E1, Keith.
I would bet that would cause an E1 error pretty quick. You know, certainly in cooling mode, right? And then we've got some dirty filters here. Those are pretty dirty. And if the filters are that dirty, you think the coil might be dirty?
Oh, most certainly.
I bet it probably is. Yep. So once you clean these things too, you know, we would recommend start the system in turbo mode, because if you power down, the E1's going to clear. And so if you restart, you know, restart in turbo mode, let it run as long as possible before you leave the job, because if that E1 pops back up, then you're back out there on another callback, and that's not good. Hopefully this is a service call that you can charge for here. How about a dirty blower wheel?
A quick, Keith, real quick, a quick check. You're mentioning, you know, reset the system, you know, pull the main power for 5 to 10 minutes. If it does clear the code, then you know it's likely something else besides a failed pressure switch.
Right, right. And we're going to talk about it a little more, but the system will try to adjust. Its desire is to keep running. And so it's going to slow down, and when it sees some of those conditions, it has logic in there to try and keep it running as long as possible.
Yes.
But dirty filters, coils, dirty blower wheel.
I've seen this a lot.
Yeah.
The filter's clean. The coil appears to be clean. Take your flashlight and shine it up in through the louver, and you'll see that the blower wheel has some buildup on it.
Yeah. Yeah. You know, it could be pet hair, it could be a number of different things, and probably particularly in the southern, more humid climates, I bet. And there are some things that you can do to mitigate a situation like that, UV lights and some other things. But that's an important thing to check, and fairly easy to clean. So what about a situation like this? Do you think that could cause a bad radiating environment?
Oh no, that looks really pretty. I like how it's concealed.
Yeah, almost completely concealed. There is no airflow going across.
No airflow at all.
Yeah, and so that one's throwing an E1. I can almost guarantee it. And then situations like this as well. What do you see that might be problematic here? I think
clearances.
Yeah, clearances. This thing is pinned right up next to the house. That's pretty close. I'd be surprised if it wasn't causing an E1.
What's the general clearance from the wall? Isn't it about 12 inches?
Yeah, it's a foot, and you know, which still is not much. It's better than a lot of conventional equipment. But yeah, you got to get some airflow around that thing, and then even in the front, you know, there's a big tree or bush growing out here that's really causing that thing some difficulty in getting rid
the
of it.
Landscapers may have just trimmed it. It may have been even worse a few weeks ago.
That's true. Yeah, this guy, just to get back in there, probably cut some of that stuff out of there. So you know, just visual inspections. Take a look around. There's probably some stuff you can clear out of there, and definitely should. How about this? You suppose that might cause a little bit of a problem?
Maybe. I would say that the one in the front in cool
Yeah.
mode is getting a little bit of a overload on heat.
Yeah, definitely. So, use a little common sense when it comes to this stuff. Also, if you're in a snow condition, you need to get these things up off the ground. These are going to have a hard time. Always consider the environment systems are being installed in. Overcharging a system will produce higher pressures in heating mode. Pressure can reach 600 psi before the system displays an E1. So these units should have been much higher off the ground to avoid snow buildup. What other problems could this cause?
And that's also local code, I believe. So be sure to follow your local code.
Yep. And so other problems, inability to defrost completely could lead to ice buildup. That ice buildup, ice expands when it freezes, and then you might have leaks in coils and all kinds of other
Fan
problems.
motors.
Yep, fan motors. Could a leak in a condenser coil cause an E1 if you're low on refrigerant?
Most certainly.
Yep, if you're low on refrigerant, the discharge pipe, you might not have enough cooling gas coming back to the compressor, and now your discharge temperature coming off the compressor is high, and that temperature sensor could trip due to that.
Trip the E1 code, yeah.
Stepper motor, not a common thing, and it's a very easy visual inspection. I mean, you can see if the louver is moving. If you come into the room and the louver's closed like this and it's in heating mode, could that cause an E1?
Yes, most
Absolutely.
certainly. I didn't even think about this when we were talking about the E1 code, Keith, and you brought this up, and it's a very good point because it's something that you would normally overlook, and I did.
Yeah, I mean, it's a simple thing, and you can check it very easily by just hitting the swing button on the remote. And if it's not moving, then you may have an issue with the stepper motor. Very easy to check. And it's a good idea when you're out there to just check through some of these things and make sure that you aren't going to end up back out there. But stepper motor, the wiring terminals, the plug on the board is right down here at the bottom right, typically. And to check it, we've got some tables and charts and things, and these will all be out there on the website as well. Look at the board diagram, and it'll show you where these different components are, and then very easy to test with a simple ohms resistance test. And these are the values you should see across the wires. We'll put all this stuff out there so it's readily available to you. Any questions coming in yet?
Not so far, Keith. Looks like we're
right?
good. We're good for now.
We're gonna have to start like typing our own questions and stuff to get the ball rolling. But any questions that you guys have, please throw them out there, and we should be able to answer them for you. And certainly by the end of the call, we're going to go through everything that you guys have on your mind. So let us know if this is helpful so far as well. We always want to do continuous improvement. So indoor fan motor. And again, that should be a pretty easy thing to visually test, see if the indoor fan is running. If the indoor fan was stopped, again, in heat mode, probably going to throw you an E1. But you're probably going to get a call from a customer a lot sooner than that because there's no air flowing in there. So that should be pretty easy to suss out. But so there's an unpowered test, ohms resistance test. Tells you from white to red should be 240 ohms and so on. Again, here's the board diagram showing you where that fan motor is located. And sometimes, and I should mention this because they show it in there as the PG motor, PG fan motor, right? And that's a pulse generating is what the PG stands for. Pulse generating motor is your indoor fan. So the powered test, this 230 volt model, while the indoor unit is running, you can check brown to white, and on the different speeds, you should see these different settings. Obviously, if you go to turbo, then you know what speed it's running at. Visual test, outdoor fan motor. So outdoor fan motor also stopping running can cause you an E1 and cooling mode. Visual test is fairly easy, but also if you can spin the motor a little bit, because, you know, maybe it's running, but it's bound up a little bit. You know, and spinning the fan blade by hand can also a physical test that can let you know if the thing is operational or should be operational. Could the outdoor unit fan motor stopping cause an E1? Yes. Right?
Yes.
Cooling mode. Then turn system on in turbo mode. Is the outdoor fan running? If so, the motor should be good. And if you need to do a powered test, this is the terminal strip on the board, and you test terminals 1 and 2, and remove the harness from the board first, and then test these terminals 1 and 2. You should have 280, 310 volts DC across there. You can also do this powered test across 2 and 3, and you should read 15 volts DC. And then there's also the harness test, and just across any motor terminals shouldn't be less than 1 KO.
Yeah. Just to you know, you mentioned, you know, pull the Molex plug off of there, you know, to test. There's a retainer clip. If you see that, the red piece there, that keeps you from pushing the plug, the clip that lets that connector off of there. You'll notice on the picture on the left there.
On the on the motor.
On the Molex plug, the red clip that keeps you from taking it. So you remove the retainer clip, and then that Molex plug comes right off of there. It gets frustrating when I'm on the phone and a contractor's going, man, this thing won't come off here. What's the deal? It's the retainer clip.
Well, we'll make sure to include that in the service manual. We'll show some good pictures and show them exactly how to do that. And in a quick tip video, right?
That would be a good quick tip video.
Yep. So troubleshooting test points, blockages, restrictions, mismatch piping. This is an actual picture that we just came across.
A friend in upstate New York sent that to me. That's the bonnet from the flare nut that it was left on and pushed its way out into the pipe.
Yep. Well, I'm sure that wasn't any of the people on this call, but just in case, you know, if you've never seen that. And I've seen plastic, sometimes a pipe will have a plastic insert in there. I've seen those in there as well. And all kinds of mayhem. But just make sure that the piping, you know, you can perform a temperature differential check to ensure piping is clear, and check for cross lines in piping. This is an actual case. You just ran across this recently, right, Daniel?
Yeah. So on a multi-zone system, the circuit, the wiring was mismatched according to which indoor that it was going to. But not only that, the refrigerant piping was mismatched with the particular circuit that it was supposed to go to as well. So it was not only confused about which indoor unit was calling for refrigerant to be metered to it, it was also sending it through the wrong pipe to a different indoor unit.
Yeah. So that can be that can certainly cause a little confusion for the system, trying to
very confusing.
So a remedy for that, like, and I could see if somebody's hooking up a multi-zone system, they're going to shove a lot of pipes through the wall at once, right? But they should tape the sets together. You know, this is set A, set B, set C, whichever set of valves you're going to go to on the system, and then same with wiring, right?
Yeah, different colored electrical tape seems to be a good idea. You know, and that way you know this one's with this one.
Right. Yeah, because that could certainly be problematic. So indoor circuit C, you said that the line, you did a 4-point temperature check.
Yes, a 4-point temperature check, and I think we'll talk more about the 4-point temperature check. But basically, what you're doing, and this is once we've ruled out all of the basics, dirty coils and all the stuff we went over, all the visual checks. This is a good check to see if there's a restriction anywhere.
Right.
And what the key was on the mismatched refrigerant lines going to the wrong ports was that the temperature on one pipe compared to the other one was way different. So the one that was calling and the one that wasn't calling, the one that wasn't calling was getting refrigerant to it when it shouldn't. So you're seeing heat there in the heat mode.
Right. And so like these bullets say down here, the EEV is located in the outdoor unit. So when you're testing those pipes on the indoor unit, the only thing that should change the temperature of the refrigerant between those two lines is the airflow across the coil.
Yes, yes.
Yeah.
And that's usually about 5 degrees difference between the two pipes. Now, I'll tell you a secret that we've learned on the flex system is if you think about where you hook up, if you're familiar with the flex, you've got service ports indoor and out. So you can hook your gauges up at both places, but there's not a true suction port. So your pressures at that point are going to be close to the same on those two pipes in heat mode, about 10 degrees difference, and you know you're in a good spot. So that 5 degree difference and then that 10 degree difference, you know, good rule of thumb to see if there's a restriction somewhere that you need to look for.
Yeah. Yeah, because, you know, the fan blowing across the coil, the refrigerant's going to pick up heat. There is going to be some temperature difference, but it's not going to be 118 and 170.
And let me clarify, on the flex, it was PSI difference, not temperature difference. On the mini splits, we're talking temperature difference.
Right. Yeah, because the flex system, it's an inverter split system, but it has two sets of service. It has two service valves on each end. On the out, two service valves on the outdoor, two service valves on the indoor with ports to put gauges on. But it's still an inverter system, so it doesn't. It's not going to have pressures like a conventional.
Right.
Anyway,
right.
We're getting off track a little bit, so
we'll get back on track. We've got a few questions. If you'd like to go over a few of them, Keith.
Yeah.
Sam Brewer is asking, does Gree make a pan heater for outdoor units in cold climates with condensate freeze up? If you want to answer that.
All Gree units come with a base pan heater installed.
Yes, already installed.
Every system comes with a base pan heater installed. Moving
forward, some of our previous models did not have, some had and some didn't have the base pan heater. Like your UMatch A revision didn't have the base pan. Moving forward, the models do include the base pan heater with all of our current models. And then we've got another question from Derek. I was told when the indoor motor goes out, you need to replace the indoor board as well. I found that to be true. After changing just the motor, we ordered a board, changed it, the motor quit working. Tech support said I was supposed to change both at the same time. That's why the new motor burned up. Is this true? It is, from my point of view, doing tech support over the phone for you guys out there in the field, I always recommend both. Even if we can, know for sure which is which, I always recommend both just in case. That's a good rule of thumb. Maybe we missed something on the phone with you or something like that. I would always get both.
Yeah, it's probably not universally true that every time the motor fails, there's a problem with the board. That's probably not universally true. But if the board caused that motor failure, right now,
right,
you want to change both just to
right.
Sure. If we're willing to send you that board, why not? Right.
That's right.
Yeah.
and
it's pretty easy to do.
And Kenneth,
and with the Vireo Gen 3 series, it's a lot easier to get to the board and make that change out, right?
Good point, Keith. You can access the board without taking the entire outer cover off, which is it's like they made it just for technicians.
Well, they've probably had enough of us talking to them about removing that whole cover, and you know, all the work that you have to do to get in
Oh
there.
yeah. Oh yeah.
They're making it
Ken,
a lot easier.
Kenneth is asking, is that field wiring and piping? I assume, yes, yes. We're talking about the field interconnecting cable and the field line set piping.
All right. So,
And one last thing, Gabriel, glad you could join us, Gabriel. Gabriel's our friend out west. Just an added note, setting the indoor fan speed to low in the heat mode could also possibly cause an E1. Yes,
yep,
most certainly. If
yep,
you're manually setting it to low speed, and say you've got some dirty filters, a little bit of buildup on the fan wheel, then you know it's not able to ramp up to remove that heat.
yep,
So obviously there's a good chance you could get an E1 out of it.
yep. So that system is trying to get rid of heat. In cooling mode, it's trying to get rid of it to the outside. In heating, it's trying to get rid of it to the inside. And anything that restricts that heat transfer could possibly pop that E1.
Yes.
So can a system be overcharged? What can happen if the system is overcharged? Well, you could get an E1, which is what we're here to talk about. And what other problems could occur with system overcharging? How about slugging a compressor? It can,
Oh yeah.
it can happen. It can happen. There's some misnomers that, and mini splits are pretty amazing. The way they operate, the way they think, the logic they have in there, self-adjusting and self-diagnosing in some cases, but it's still a mechanical system that has parameters, and engineers laid these things out, designed it, and have these set parameters. So, you know, you should really stick to those parameters. Overcharge system, you know, can display higher pressures, but and you may see huge increases in pressures in heat mode. But all mini splits have an accumulator. And, you know, some multi-zone systems may have two. This allows the excess refrigerant a place to go when the system slows down. So a couple little slides here. Refrigerant in the, you know, on the suction line enters the accumulator. The accumulator holds the excess refrigerant when the system slows down to low capacity. And they do have a screen in there to help protect it from some debris. And then the suction tubes just below the screen pull vapor from up here, and then the liquid stays down below. So like little snorkels, right? Refrigerant will be in the lower part here. Suction always enters through here, so you've got a little bit of protection. But if it's overcharged, is there a chance that the refrigerant could flow in and go above that screen and then get sucked down into the suction side? Yes. And then, you know, you've got bigger problems than an E1.
Most certainly.
Okay. So system overcharged. A couple ways, you know, you can put some gauges on there, check the pressure to see if it's a pressure switch, they trip above 600. If it's a sensor, you know, it's taking that information, showing it to the board as a resistance value, doing some calculations. They do have some internal protection. So the system will slow itself down to try and protect itself. Again, its desire is to keep running. And, you know, we want them to have heating and cooling. It's not going to run indefinitely, though. If it finally decides, if it runs long enough and sees a certain condition, then it's going to protect itself by shutting down and displaying that E1.
I had Keith, I had one the other day that it was a code, a low pressure code. No, the end result was low pressure, but the code was reduced frequency for low pressure. So it reduces frequency of the compressor and adjusts the EVs to try to continue running, even though it doesn't have the proper charge that it needs to continue doing the job that it needs to do. So
yeah, pretty amazing. But you can perform a temperature differential test of supply and return air. Delta T should be about 20 to 25 in cooling mode, 25 to 30 in heating mode, and you're trying to test as close to where the temperature sensor is, right? The ambient temperature
Yes.
sensor.
Yes.
So when you're performing your test, try and be as close to those as you can in cooling
Or
mode.
the return and supply as close to the actual return and as close to the actual supply as you can get.
Yeah. And then, you know, the only way to really be certain about your refrigerant charge, 100%, I mean, 99.9% certain about your refrigerant charge, is to recover the refrigerant and then weigh it back in according to the factory specifications and any line length that you may have added. The other thing, and Daniel mentioned this morning, is when you're recovering refrigerant, let's say you're going to pump a system down and recharge it. When recovering the charge, weigh it out as
Yes.
well, so you can determine if the system was charged correctly.
And then you already you know what you're dealing with before you even start the evacuation process.
Yeah, real good tip. So then next we have temperature sensors. What if you have a bad sensor? Could that cause an E1?
Yes.
Absolutely, right? And so there's 5 sensors located in the system that can be easily checked for proper function. But like if a sensor was a problem, could it have possibly displayed an F1 or an F2 or one of those F errors first, or, you know, an unhappy customer calling you up to say this thing's not working right? So sometimes, you know, you may get another call, but yes, a bad sensor can certainly lead to an E1. Return air temperature sensor is located usually down here in the bottom right. You see it located there, the yellow sensor. And then the indoor pipe sensor is up here on the evaporator, and there's a little close-up shot. And
that sensor during heat mode is monitoring how hot the indoor coil gets. So if it's not able to remove enough heat, then it could throw the E1 error code as well, because it's sensing that it is over temperature.
Yeah, and it's determining the fan speed.
Yes.
And it also sends a signal to the control module with other sensor inputs to control the flow of refrigerant through the EEV. Outdoor temperature sensor, and we'll talk a little bit more about that.
Believe it or not, I've actually had an E1 on a system that was on a roof out in Arizona during the summer.
Yeah, that's not surprising. 135 degrees on the roof.
Yeah, blistering.
Yeah. But a couple of things to remember too about outdoor ambient sensors is, you know, it's important to locate the system so it senses proper airflow. So consider things like prevailing winds, sun exposure, other weather conditions, or things that may block accurate readings.
Dryer vents.
Yeah, dryer vent. Yeah. Yeah, or a bush, or, you know, being too close to the house. You know, if it's not able to draw the air across there, it's going to be it could throw a reading. So then this is the condenser coil sensor, and you know, senses the temperature there right on the pipe, and then does calculations in the board to figure out what to do with the EEV and all the rest. Discharge temperature sensor. It's not a safety switch. Sends information to the board, and like we say, it'll you know, it'll slow down a little bit to protect itself if it's sensing high temperature there. Another thing that can occur, and this came from Richard in our tech department, but he's had situations where mud daubers or dirt daubers pack mud up inside the plastic portion of this sensor tube here, and throw off the reading through an E1. They've seen spider webs. What else? I mean,
yeah, anything that even like not all of the discharge temperature sensors, not all of them are clip-on. Some of them have a little tube that the sensor slides in, And if anything is causing that tube to not be close to the pipe, spider web or whatever that got in there, it could cause an E1 error code or an erroneous reading, even though the sensor itself is actually ohming out properly. You know, if you're not doing a visual check on the sensor, then you could have something like this going on.
Yeah, yeah. And we've got a suggestion on a way to maybe test these in our tips and tricks section. So testing temperature sensors using an ohm meter, check the resistance value across the leads based on temperature, current temperature. The value should be close to the values on the tables. And we just put some updated tables out there for you too, to make it a little bit easier. Got an example of that here coming up.
Don't forget, Keith, if you don't have some needle point adapters for your meter, go ahead and get some. You're going to need them one day.
Yeah. Yeah. Sometimes it's really hard to get down in those Molex connectors.
Yes. This makes life a lot easier.
Yeah. Yeah. So yeah, thanks for pointing that out. I always mention that too, but temperature sensors. Now these are the board diagrams again, showing you where the sensors are located. You'll see, that sometimes I'll have the values in here, 15K, 20K, 50K. They don't show that on the indoor, but ambient temperature sensors are always 15K. Tube sensors, evaporator, condenser are always 20K, and then the discharge sensor is always a 50K. So that kind of helps. You'll find the diagrams in the service manuals,
mm-hmm.
and the service manual that we create is going to have all this information and Molex connectors and where to put the meters and what readings you should get. We'll have tables for everything. So I'm working on those now, and we hope.
And generally speaking, as you can see in the previous picture, Keith, the color of the wires going to the sensors. Now this is generally speaking. There may be a few different ones in the older versions, but from all of the current models that I deal with, I see the white being the 50K, which is the discharge. I see the yellow always being the ambient sensor, and it's also the entire wire, and the sensor itself seems to be indoor and outdoor ambient is yellow, so it's easy to recognize. And then the black wire is the 20K coil sensors, and on the multi-zone you'll see several of the black wired 20K sensors on the outdoor.
Yeah, that is helpful. So just at a glance, you should be able to tell. So the sensor tables, this is what we put out there. So this has both Celsius and Fahrenheit, and that conversion table can come in handy for some of the other tools that we have if you're using a debugger, which we're going to cover here in a minute. But we've got Celsius, Fahrenheit, all the resistance values for 15K, 20K, and 50K all sitting side by side, and covers the full range of temperatures for the equipment. And
I just have to say, Keith, that's an excellent table that you've built there. Can you explain the highlighted portion of it?
That comes up in our tips and tricks.
Okay, gotcha.
So then high pressure switch. If the system has a high pressure switch and it trips, the entire unit shuts down. This is the description out of the service manual. When outdoor unit detects high pressure, switch is cut off for 3 seconds successively. High pressure protection will occur. You get the E1. All loads except the 4-way valve, which is energized in heating, but all loads will be switched off. The reversing valve will continue to be energized. In this case, all the buttons on the remote, except on and off, will be disabled, cannot be recovered automatically. Switch off the unit and re-energize after cutting off power to eliminate this protection. Well, it doesn't eliminate it. It doesn't fix it. right? Cutting off power doesn't solve the problem. It just clears it until the problem displays itself again.
Right.
So what's your opinion, Daniel, on the likelihood of that occurrence happening?
So, you know, if you just go out there and you pull the power, do a hard reset, wait 10 minutes and it clears the code, chances are you're not dealing with a failed pressure switch, correct? But you're going to eventually get another E1 error code, whether it be, you know, after you get home and sit down in, you know, your recliner to do your service reports, the customer calls you back. So, you know, it's important to not just reset but to inspect and test everything.
Well, would it be beneficial, like they get a call from a customer, hey, I got this unit, it's showing an E1, have the customer cycle power off and turn it back on, and okay, if it happens again, call me, because then you're going out there for an E1.
Right. Yeah, that makes sense. Yeah.
So let's see. So this is what it looks like. Again, the board diagram showing you where the high pressure switch is at. If you're curious whether or not a system has a high pressure switch, this is a good way to figure it out. Look at the board diagram. This thing trips at around over 600. 609, the switch opens. 522, it closes back. And this is where it's located. It's discharge, so it's off the compressor discharge line. Should be pretty easy to find. That's what it looks like. And make sure the switch is connected well at both ends on the board and the terminals on the switch itself. Check the system using the gauge. Pressure is high. Again, that 600 range. You can perform a continuity test on that switch. Just pull the wires off and remove the two spade connectors and put the meter on there, and it should show continuity. If it does not, replace the switch. You do have to, well, and another test you can do, you can simulate the E1 by removing one of the leads from the high pressure switch, if that is helpful. And then to replace this switch, cut the zip tie off there, remove the insulation from around it, take the wires off, and now you've got to braze it in. So if you're going to replace one of these switches, please use some kind of thermo trap or some type of a heat absorbing compound. A wet rag works fine, but make sure to protect that switch and anything else that's around it.
We don't want to melt it while we're installing it, right? No,
that could be problematic. You might get another E1. Of course, then it might be welded closed. So the EEV can also be a problem. On mini splits, the EEVs are located in the outdoor unit, and they're going to be on the liquid line just after the strainer / muffler and before the service valves. Multi-zone systems will have multiple EEVs in there, and as you can see, they're labeled in there AB, units AB, and then the coils are easy to check and inspect and change if necessary. So the way this thing works is warm liquid is entering in, needle valve rotates by the pulsations, directional pulsations given to the magnetic coil, and spins clockwise to close the needle down, spins counterclockwise to open the valve up, and they provide extremely accurate refrigerant flow of 480 steps to be fully open. 0 to 50, they call that fully closed, but then there's 480 steps for this thing to open and close within this range here. But you can see it's a real tiny little needle valve, and these things close off completely. At system startup, you'll hear that little ticking sometimes if you're outside, tick, 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 tick. And that's that valve driving all the way closed before it receives information from the controller and decides how much this needs to open or close.
So as you can see from the opening there, if you forget to deburr your flares and a piece of copper happens to make it past the strainer, then you could have a blockage there, couldn't you, Keith?
Sure. Yep. And that's why we don't allow desiccant dryers, brazing without nitrogen, a number of things that can cause problems in here. One tiny little piece of debris can cause that thing to stick and not function properly. Another thing that can happen, and this is an easy visual inspection, pull that coil off and just take a look inside. Corrosion can develop over time on the inside of the EEV coil, and environment has a lot to do with it. If you're in a cold, wet, environment, or I guess even some condensation and things like that can be problematic. So clean the inside of this thing. If you see it dirty like that, clean it with some fine aught steel wool. Clean the post as well. The magnetic coil transmits the directional pulses to the post, which spins a needle inside the valve, as we saw in the last slide. If the signal is interrupted, obviously it can cause a problem. Coils are easy to replace.
One note on that, after you get it good and cleaned up, Keith, is to use some type of lubricant, just to try to keep corrosion from happening again on it. You can use any type of lubricant and just a thin coat and put it on there.
Yep, good point. And so here's some other examples that, you can see these things are pretty crusty in there. Clean them up. If they're still not functioning properly, you may have to replace them if they've been installed for some time. The other thing that can lead to is damage to the PCB. Occasionally, if that moisture is in there, water and electronics don't mix too well, and you could end up with something like this. So just something to keep in mind, something to check. If you've done the other checks, as you're going down the list, we're getting harder and harder. If you've done the other checks and you haven't fixed the problem yet, then you got to keep going, and this is the direction to go. So like
I've actually had several instances where a board was replaced and it turned out an EV was shorted, and it ended up causing damage to the new control board. So that's a good thing to, if you do have a reason to replace a control board, inspect that control board too, just to make sure, okay, does it have a burnt spot, and if it does, trace that circuit down just to make sure you don't need to look at other components.
Yep. Yeah, really good point. And so you can replace the coils very easily. They pop right off there, and then the harness, you can unplug it from the board and fish a new one in there. If that's necessary. If you have to replace the entire valve, again, you've got to braze it in there. And so this is what the part looks like that you get. And again, use some thermal paste or a cloth or something to protect the valve.
And flow nitrogen.
And flow nitrogen, yes. Thank you. So test procedures, temperature differential on the EEV. When system is running, use a digital thermometer to test the input line compared to the output. There should be higher on the input than the output. If they're the same, EEV could be stuck in the open position. A couple of things that you might be able to do to resolve that issue. We're going to cover that in our tips and tricks. Then other testing procedures. So we've, and this is all going to be out there, and again, is going to be in our service manual. But select milliohms on the multimeter and put the red lead on the metal tab on the bottom of the coil.
Mm-hmm. Is that the tab that holds it on when you twist it? Okay.
Yeah, it makes contact. It's a ground tab basically. But so you put the tab there, and then you can check across any of the pins in the Molex connector. They should, and we'll spell this out, in the manual. But
so it should all be
fine or
open.
100 milliohms,
yeah.
And then EEV testing. So this is another unpowered test. select 200 ohms on the multimeter. Resistance should be 46, plus or minus 3.6, so somewhere in this range. And this gives you the wires to test across and what the reading should be.
It looks like someone needs some needle point adapters for their meter on that last picture.
Yeah, no doubt. No question. Yeah. So you can check to see if the printed circuit board is putting out power to the EEV. The connector here, you just go to the pins 4 and 6. You should get 12 volts DC on those.
Now, if you're doing this, you want to be careful because you've got power to the unit, right?
Yeah.
Okay. Yeah. Just don't touch anything on the board.
Yeah. Power test. Yeah. That they can bite you. And then, so what about a sticky EEV? You can have huge fluctuations in pressure. Stuck fully open could cause excess cooling, frost on the evaporator. Stuck fully closed can cause no cooling, warm air in the evaporator, suction pressure nearly equal to standing pressure. No gas discharge on liquid valve, overheating in the compressor, high discharge temperature. There's our E1. Systems will slow down to protect the compressor, though, at least. So we do have an interesting tool now. If any of you do not have a Gree mini split debugger, you may want to consider investing in these. They really, oh, here's Daniel's got one.
Yep.
So everybody's jealous. But you can tap onto the system wiring at the indoor or the outdoor unit and test a lot of different system functions. So you can verify sensor readings, verify data using the debugger if E1 occurs and under what conditions, simulate indoor and outdoor unit on the mini splits, and then some of the other ones that shows both values. Perform calculation between discharge temperature sensor, condenser sensor, outdoor ambient. It shows you all those values. So this is kind of what it looks like, display screen and function buttons, the power cord plugs in, and then these terminals connect to the unit. And safety first, power off the unit. This kind of tells you how to hook it up. Make sure your connections are not crossed or you'll get an E6. And again, all this information will be out there for you to download.
That's actually in the manual that comes with the debugger, right, Keith?
Yeah.
Okay. So just to kind of clarify, there's the single zone and then the multi-zone debugger. The single zone is going to read whichever unit you connect it to, such as outdoor, or if you connect it to indoor, it's going to give you the indoor readings. The multi-zone, as you can see here in this example, it's going to give you indoor and outdoor readings. So you don't have to run up and down the steps trying to determine if unit A is in high fan speed mode and what the indoor temperature is on it.
Yeah. And you can see a lot of different values here. It's telling you the operating mode, where the EEV is. It's at the 175th step. And then to close down pretty, fairly tight, right? If 0 to 50 is considered closed and 480 is considered fully open. And the temperatures and things are displayed in Celsius. We're sorry about that, but that's what we got. And
just keep your conversion chart handy.
Keep the conversion chart handy. It's still a fabulous tool to have in your arsenal. It'll save you so much time and trouble. It's performing all those checks for you without having to hook up a meter. Tells you it's a cassette, and fan speeds, tube temp, the whole thing. And then this is the outdoor unit. So this is showing you both. As you can see, like on this last slide, you see all those number of screens that are down there, a lot of different values that it can show you. And then same for this. So this is the outdoor unit state. It's in heating. And these, you can see the EEV 479, 480, those are fully open. And various temperatures and anything to add? Daniel?
Yeah, the important thing to me here is that you can you can see what your temperature sensors are reading, or at least what the system thinks that they're reading. So if they're out of a range that you're looking for, then you can go, okay, let me get my meter out of the bag and check that particular sensor just to make sure that it's reading correctly.
Right, right. So it's doing a lot of troubleshooting for you, getting you to the right, how did Dwayne say that? It gets you to the right street, not necessarily the right address, right?
Yeah, exactly.
But it's helping you dial in so that you do less work, fumbling around trying to check everything independently. And showing the readings in Celsius. I converted them down here, but this function detects the operating parameters for the whole unit. And this is is this the mini split?
This is the single zone one that you were looking at, not the multi-zone. So you are able to see, if you're hooked to the outdoor unit, you're able to see the outdoor ambient temp that it thinks it is. You can compare that to see if it's correct. You can see what your discharge temp thinks that it is. Compare that, take an accurate reading off of the discharge pipe and see if it's fairly accurate within, plus or minus 10%.
And so this is an example of the mini split one, right?
Yeah, the single zone. So you've got your 1, 2, 3 wires hooked up, and you can hook up to the indoor or the outdoor, and read all the parameters from that particular model or particular unit that you're attached to.
Yeah. So if you hook it up here, you got to disconnect on the indoor and vice versa. Right? So tips and tricks. We thought of a few things that might be very helpful to you in the field. But again, cycling power, we just kind of wanted to touch on this. You don't want to call back. So cycling power and clearing the E1 is not necessarily a solution to the problem.
Right.
It pays to go through the checks. If you're already out there, it pays to check the filters and the coils and stuff for cleanliness. That is probably the most common cause. So, and it may clear and not turn back on. Talking with Richard too, he said, yeah, he's tried to mimic problems like duplicate an error code, and the systems, because their desire is to run, are trying to think around that problem. They're trying to find a way around it.
Yes.
So it's hard to get it to duplicate an error.
Yeah. Sometimes it just, I believe it goes through, not the E1, because the E1's a safety, but a lot of the codes, it'll go through a series of 5 to 7 times of attempting and seeing if there is a code that comes up before it actually locks out. So it could be occurring at the moment. It's just not locking out yet because it wants to continue providing cooling or heating.
Yeah. So cleaning filters and coils. If the filters are dirty, could the coils still need cleaning?
Yes.
Very much so.
And
vice versa, right?
And vice versa.
The coils are dirty, filters could need cleaning. If there are obstructions, would it still be wise to clean and clear everything every time, right? One of the things to keep in mind is that all Gree units come with standard bluefin coating, and some of the outdoor units even have goldfin coating. It's an acrylic resin coating that resists salt spray and corrosion. It also helps with heat transfer and it helps to keep things from sticking to the metal. But you should only use a detergent when you're cleaning these coils. Don't use an acid that could etch away some of that acrylic resin coating. And there's a bunch of different brands out there. This is a Rector Seal product that's been designed for cleaning mini splits. New Calgon has Tri-Power. This is Diversitech Triple D. These are all concentrated detergents, and they will do a good job at removing some of the dust and dirt and things without damaging that acrylic resin coating.
Don't forget the blower wheel.
And the blower wheel, yeah, yeah.
Clean that thing off.
Yeah, I'd pull that out of there and take it out and clean it. But this is what the Dissolve kit looks like from Rector Seal for cleaning the indoor coils. It's got a bib, and there's some other kits out there similar to this, but the bib helps to contain this runoff from this down into the bucket, and that's a pretty good tool for
keep from making such a mess.
Yeah, yeah.
Either that or take the unit off the wall and take it outside.
Yeah. Then you're going to charge the system again and all.
Yep.
So, one thing we thought of for sensor measurements, if you can get a glass of ice water to the lead to the end of that sensor, ice water is always 32 degrees. So now you don't have to worry about having your temperature chart. You only have to remember 3 values, right? Because if you're always testing at 32 degrees, now I only need to remember 49 for a 15K, 65, and 161 for a 50. That way, doesn't matter what the ambient temperature is. You're always going to be accurate. So whether it's hot or cold outside, let's say it's colder than 32 outside. When you put that down in the ice water, it's going to still take it to 32. And so you're always going to know that you've got a stable reading, a stable temperature anyway,
right,
that you're putting the sensor in. The environment's always going to be the same. And then just, commit those to memory, have them on your phone, little picture of that or whatever. And then you don't have to remember all, 800 different values, or you're not married to the chart. 4-point temperature check. This is what Daniel talked about earlier. And
yeah, I'd like to explain a little bit more about that 4-point temperature check. It sounds confusing, and it sounds a little confusing when you try to explain it over the phone. So what we're saying there is that you're taking the temperature of one copper line, not the line set. You're taking the temperature outside as close to the service valve as you can get, and inside as close to the manifold of the indoor coil as you can get. Sometimes that would mean removing the outer shell of the indoor unit so you can see the coil and everything if you can't get to the back of the unit where the line sets come out, but as close to that manifold where it enters the indoor coil. Those two temperatures should be almost the same, within 3 to 5 degrees of each other, indoor and out. If that is true, then there's no restriction in between the indoor and out in that particular pipe.
Very good. Very helpful tip. So talking about that sticky EEV, these are permanent magnet EEV magnets, and there's 2 sizes because there's a couple different sizes of these the body on the EEV valve itself. Mm-hmm. So these are designed to fit, just around those nicely. And you can use these things to turn that piston inside there, just like turning on a faucet, opening and closing a faucet. And sometimes if there's a piece of debris or something that's preventing or causing that thing to stick, you can spin those EEV magnets and loosen that up and maybe free that up. That would be a lot better for me than having to replace this and braze a new one in there.
Yes, most certainly. And also it's good as a test tool to see if your EEV motor is actually moving it or not, or if it's stuck.
Yeah. Yeah. You could open it up fully and listen for that thing to drive down and then open back up again. When you power it up, they drive fully closed and then mm-hmm. they'll reopen. So might be a good idea to cycle that all the way open, but makes a real easy method for doing that. So just to recap, we covered 11 different things here. Outdoor ambient too high. We've got charts out there for you. Are the service valves fully open? Easy thing to check. Dirty filters and coils, probably the most common thing. Again, easy visual check and should always be done. Is the stepper motor functioning properly? Indoor fan, condenser fan. Is the system overcharged or is it low on refrigerant? And then are the sensors functioning properly? If it has a pressure switch, is that functioning properly? Easy to check, not as easy to change. Is the EEV functioning properly? So all these steps should be things that can get you in the right, in the right area to fix that problem. Hopefully fix it quickly, like in the early stages of that list.
Excellent.
So tech support department does have some requests. I'll let you go through those.
Please help us help you. If we don't know what you're working on, then we can't help you. When you're reaching out to us, please, if you're sending an email to techsupport@twclimate.com, or if you're calling us on the 888-850-7928 number, please be sure to have your model and serial number ready, and your company name. Let us know you're a contractor so that we can get back with you as quickly as possible. Don't forget to leave your phone number and a brief explanation of the problem, such as, hey, I've got an E1 error code, I need help. And that helps us go ahead and get the service manual pulled up for the correct model. And that way we can get back to you a lot quicker and get you the help that you need.
Yep. And please be sure to check on the greecomfort.com site and look at those quick tip videos. We're going to add those all the time, and hopefully when you do have a problem, you can go check and see if there's a quick tip video on it. It might just help solve your problem. Other pieces of information that we're going to put out there, and eventually a phone app, so you can have it right there in your pocket. You can diagnose error codes, piping rules, and submittals will be out there, and just a variety of different things right there at your fingertips. And
don't forget that the QR code on the newer models on the outdoor near the data plate, you scan that QR code and it takes you to the quick tip videos, and Keith's adding quick tip videos all the time. And so you can just scan that, take you to the quick tips, and hopefully get the problem resolved as quickly as possible.
Absolutely. And don't forget about our social media sites, Facebook, Instagram, LinkedIn, Twitter, YouTube. We're gonna push some more YouTube videos out there as we go, but we're just starting our training season now, and hopefully we'll see you guys out there somewhere. Training class near you. If you're not already a Gree Select dealer, please attend one of those classes and we'll get you signed up as a Gree Select dealer. There's a lot of perks that come along with that. No cost to you, just your time. So we appreciate you guys very much. So did any other questions come in while we were?
Yeah, we had a few questions come in, Keith. Scott is asking the new service manuals, how soon can we expect them to be available?
So the new service manual is kind of a culmination of all the materials that I'm working on.
Mm-hmm.
And I've put a I don't want to I put
Next
a date
week?
out there. Yeah, exactly. I put a date out there to Suzanne the other day of April.
Excellent.
So
excellent. So that is excellent. Right as we're going into cooling season, getting into the busy season. So look forward to some more detailed information. That's a lot of what we've been missing. And it's a matter of Richard's hard work and your hard work and the team's hard work to find test points on control boards and determine what the values should be, and looking at testing motors and things like that we've been lacking on in the past. But changing that is I feel like that's gonna make the contractor's job so much easier, to be able to have at his fingertips the test points. What do I need to test on this control board? So looking forward to that, Keith, and I'm glad you're here to help us get that changed. Another question from Alan was, where do we get a debugger from? That's an excellent question. Reach out to your local sales rep, and they can get you the part number and place an order through your local distributor for the debuggers. There's 3 different ones. One's the single zone 115 volt model, one's the single zone 230 volt model, and one is the multi-zone debugger model.
Yep. So troubleshooting tools, I mean, that's what we want to try and put in your hands. And we also have on the website the Zendesk, and Daniel and Richard and other people have been adding a lot of material to that. And so there's really good information there as well. Some of that I scraped out and used for this presentation as well. So keep an eye on that. How do they access that?
So all you have to do is reach out to the tech support team, and we can send you the troubleshooting that we've built. So we'll send you a link with, for instance, the E1. We can send you the link to the rundown of the E1, so you can see it in an email.
Yeah, perfect. So any other questions?
Looks like Sam Brewer's got a question. Looks like he's talking about pre-insulated line sets, moisture between the foam and the copper was forming corrosion, eating holes in the line sets. Have you seen anything on this? I have had a couple of instances where I've heard about something like that, but it's, that's something that's manufacturer related to the line sets itself. We don't, Gree doesn't manufacture line sets, so it's not something that I've looked into or seen myself. Have you, Keith?
I've heard of it over the years, here and there, formicary corrosion, right? And so I don't know. There's been a lot of discussion about whether it's the insulation itself, the rubber type insulation or others, but insulating the lines for us, you insulate both lines, and especially for the indoor portion of that, most of that's to carry condensation, right?
Mm-hmm.
Any condensation that forms, and so there is going to be moisture there, but yeah, I don't know a solution to that.
Yeah, he was saying that seal the ends of the insulation with some tape, which seems like a good idea. I think any moisture that's kind of in a place where it shouldn't be, it could be an issue. So and then Scott was asking about, can you tell us more capabilities of the upcoming app that you're talking about?
Yeah, so the app, I'm not a code writer, so it's fairly simple, but it will be useful information. Like I say, if you're trying to find an error code or a submittal or piping rules or technical information, hopefully, and it'll have links to the website and catalog and various other things as well, maybe even our service manual, that type of thing. And some of those you'll be able to access without an internet connection. So if you have the app on the phone, you can pull it up, and some of those pages will be accessible, and you can blow them up, so you can read, like if it's smaller print, you can blow them up and read the values and things.
Excellent.
Yeah, and if we I'm, like I say, I'm not a developer and a code writer and things like that. So my capabilities are going to be fairly limited as far as what I can put out there.
It's going to be excellent.
It's going to be amazing. Yeah,
it's going to be amazing.
But there's other tools in there, and as we dig deeper, if we can find somebody who's more knowledgeable than me on
even the simple things such as the ohm chart that you created, and just to put that on the phone app, so if you're out there testing sensors, push a button and there you have what you should be reading. Right. So that's really useful. A few other questions. Elliot Ross is asking, he has a Vireo 36K every winter. He's getting an E1 code, pulled and weighed charge, check the pressure switch and sensors, reset, and it runs days, even weeks before an E1. Any suggestions? I would have to say, Elliot, reach out to the tech team and be happy to go through all of the checks that we went over here on the webinar today and go over those in depth while you're on the job site with a tech on the phone. And also pictures of your indoor unit, your outdoor unit, your wiring. A lot of times, like we were saying in the beginning, the interconnecting cable being possibly damaged, frayed, or something like that. I've even seen an interconnecting cable that's brand new be a problem because there was a problem with the manufacturing of the wire. There's a lot of different things that it can be. Like we said early on, it's just a symptom, right, Keith? So
Yeah.
we've got to, from start to finish, what can I roll out, and then what's left that I can check or change. Rarely have I seen a control board be an E1, but I'm not going to say never. So thanks, Elliot. Yeah, please reach out to us and we'll be happy to help you with that. Scott says great information. And then Kevin says, does the multi-zone debugger also take care of the single zone, or do we need to purchase both units? So the multi-zone will only hook up to a multi-zone because it plugs directly onto the control board. The single zone, however, will work with a multi-zone. In other words, you can hook it up to one indoor circuit for the multi-zone system to read that one circuit, but you wouldn't be able to read indoor and outdoor and not have to run up and down the steps with the single zone. So, and that looks like all of it. Let's see. Sam Brewer, can you elaborate a little bit on the flex unit systems? I think they are non-communicating as well. He's correct, right, Keith?
Yep. Yeah. So the flex systems use 24-volt thermostat, heat pump thermostat, and that's a good thing because it allows you to then use that inverter outdoor unit with a furnace and an A coil. And we have outdoor unit and approved A coils that meet certain SEER ratings. And then as long as the blower characteristics for the furnace fall within a certain range, then you're supposed to be able to use anybody's furnace with it. And or you can use the air handler that comes with the system. Minus 22 Fahrenheit heating, just amazing technology. It's really, really awesome stuff. And inverter split system is going to be a big thing.
I'm excited about the flex. Everybody across from one coast to the next is talking about it. And I've got a few installed myself. Really excited about the product and looking forward to more and more people getting interested in learning more about it. And then we've got a couple more questions. Looks like we're about out of time. We'll wrap it up. Wayne, is there a debugger for the UMAT range? At this time, we don't have a debugger for the UMAT, but we are working on it. And then Vincent, why do you make so many different models of high wall indoor unit, Levo, Vireo, etc.? Keith, why do we make so many models?
It just has to do with SEER ratings and
Yes.
capacities and temperature range, temperature operating range and that kind of thing. So they're always chasing the highest SEER rating possible. Sapphire Series 38 SEER on the 9,000 BTU, minus 22 Fahrenheit heating. It's amazing, technology. But then, not everybody lives there. Most people are kind of in that 23 or 16 SEER range. Some people want a price point, so we kind of have to have all of it.
Makes good sense. All right. Well, that looks like all we've got for today, Keith. thank everybody for joining us today. It's been good to go over the E1 again, especially during heating season. Thank you, everyone. Have a good day.